Good morning, everybody. Welcome to the presentation on behalf of the Edge Protection Federation, Safety and Security in Edge Protection. I'm Dave Ford from Easi-Edge, one of the founder members of the EPF. So, very briefly, who are the EPF? It was a federation of companies that came together with the advent of 13374 coming out of Europe for proprietary edge protection systems. It soon became very popular to have proprietary for a number of reasons, and it was felt that there was a federation should actually provide one voice. I think we've all seen edge protection of a similar ilk when we've been on holiday. They call it edge protection, I call it lethal. I think it's fair to say. What is slightly more dangerous is that I've seen systems out there in the UK that claim to be edge protection, look like edge protection, but are not edge protection. So where should edge protection be applied, and what is its defining applications? Well, as you can see there, it's on a number of scenarios. It can be from vehicles, it can be from buildings, it can be residential, it can be on a timber frame, and so on and so forth. It can be on a hole, as long as there's a fall involved and you need to protect that edge. So we need to look at some of the safety requirements for edge protection so that it actually shows you why it is edge protection. First and foremost, where it's all grown out of is obviously work at height regs. Very simply, as you're probably all well aware, there's a hierarchy with work at height regs. Avoid the risk, don't do the work at height. Don't actually entertain that risk. If you have to, prevent the fall. If you cannot prevent the fall, try and mitigate the consequence of that fall. With edge protection, because it's a collective measure, you're not relying on any one operative to provide their own edge protection. It takes precedence over other personal measures. So, reliable systems that are out there that are being used, and they've been used in a number of applications, here on a steel frame, here on a structural timber frame, here on a concrete frame. Different methods. Actually providing floor to soffit edge protection, still on the same compliance. And then right at the roof line, we're looking at a netting system. And then on larger builds, particularly with concrete frames, you're looking at climbing screens, like so. It's high design standard. I'm going to go on to the scope of the standard. But all EPF members have to comply to one of these three classes at the very, very least. So that standard actually covers both flat and inclined surfaces, so different pitches as well as the flat. And temporary and permanent in some scenarios. These systems have energy absorption requirements, because obviously there can be a lot of kinetic energy on the impact. So these classifications, Class A is a static load and up to a 10-degree pitch. Class B, static loads and low dynamic forces and up to a 30-degree pitch, or up to 45 degrees if it's less than 2 meters. In Class C, high dynamic forces, you're going to go at a rate of knots, and up to a 45-degree pitch. So, what does Class A mean? You can support a person leaning on that protection, walking beside it, arresting, walking or falling, and up to a 10-degree pitch. Now, to actually test for that, you can see there that they've got at the top 0.3 of a kilonewton, or 30 kilograms of force being driven across that actual barrier there. Now, when I'm asked what's a quick and simple way of testing edge protection systems. If you put a small push against an edge protection system, if it goes beyond sort of 2 inches and doesn't come back, you've got a problem potentially. It may not comply. Very, very simple test. The Class B, now this is tested under impact and you're going up to a 30-degree pitch. And you can see there that the actual forces involved on this are far greater. You can see there 1100 joules up to the 200 mil or the kick flap, and 500 joules at all higher parts. So that's quite some force actually being applied to that barrier there. And Class C, now this is high dynamic forces, such as the scenario of a 45-degree pitch and the guy falling straight down it. Ordinarily, this tends to be netting because, quite honestly, you build up a bit of speed, the last thing you want to hit is a metal barrier. So it tends to be a netting system, becomes Class C. In terms of gaps, Class A is 470 mils, or sometimes 250 if it's not got a guardrail. Class B, 250, Class C, 100 mil. And to illustrate that, Class A beach ball. I used to say medicine ball, but apparently it showed my age. B is a football, and C is a cricket ball. Very simple test. So if you think a football will not go through what you're being told is a Class B, it's not. Well engineered and simple fixing designs. It says on the byline there, EPF members have been very active innovators. They have, because they've been listening. They've been a really good listening ear to industry about what you require. So there's a myriad of different fixing designs for different scenarios, and all of which will make sure that the system will work time and time again. Well-trained operatives installing. Essentially, if you want a toolbox taught, have a toolbox taught. But there is training centres, dedicated training centres around the country. 3 at the moment are accredited, and they provide a full training for each system. Minimal reliance on PPE. You see that job there? It's 14 stories in the centre of London. Not one single metre of that edge protection was installed at height. Every single last bit of that was installed at ground level in the centre of London. Again, ground level installed. Things like stair protection doesn't have to be difficult, awkward or frightening. It can be installed at ground level. And if you have to work at height, do it from a mute. The days of steel walking are thankfully over. There is no need to do it anymore. Right, so the recognition of risks by contractors. Too often late stage involvement for edge protection. We have a very daft saying, but we call it Project 49 because on the list of 50 things which come just before the office cap. And quite honestly, obviously working at height is the most dangerous thing you can do in a lot of construction projects, and yet edge protection is way down the priorities. It shouldn't be. I'm bound to say that, but it shouldn't be. Demands in excess of 13374. When it says there optimum steel engineering, I think that's a euphemism. I think it's being polite. To my mind, a lot of the time, value engineering is more likely to hinder compliance with 13374. It's all right skimping on the steelwork in particular, but when it gets to the point where it will not take the loads of the edge protection, but it will just take the cold roll, we can't work, and neither can you. Full height protection. Some people want it, some people don't. Nobody's got any sort of consensus as to where they're going with that. Lack of adequate training. It's like everything else in life. You can have the best system in the world, but if the guy's not trained to install it correctly, well, he's going to be carrying it on his way down. To back that up, obviously good inspection regimes. The nice thing with proprietary systems are that it's very, very visual. So if somebody alters or changes it, you can tell straight away. There's none of this having to put your hand on it to check it. You can usually see straight away. It's a very visual product. Thank you very much. Any questions?